So when you first see a problem like this, you do want to take the time and strategize how you're going to approach it. But once you've done that, then you got to find a strategy. Now, one strategy is to just kind of write down for each one, kind of where does it start in that pattern? Middle, top, middle, bottom, middle, top, middle, bottom. Where's it starting in that? That's one way. Or another way, which is really getting at some of the same ideas, is you could actually sketch a graph for each one of these equations. Now I'm just going to do it for the 3 on the left, because that should be enough for me to be able to use the stuff on the right and find the one that matches it. So for each of these, sine of x. Sine of x starts in the middle, remember? And then it goes top, middle, bottom, middle. So I can then just look at that when I get to the right side. Let's do that for the others. Cosine. Cosine normally starts at the top. Where does negative cosine start? Bottom. Yeah. So this one's going to start at the bottom there, and then it goes into the pattern from there. And finally, the last one, sine of x minus 270. The minus 270 means it starts at 270. And remember, sine starts in the middle, so that's why that's middle. And then it goes to the top, because that's what sine does. Starts in middle, goes to top. Then if I follow that pattern going right to left, I can then see what the graph is going to look like. So now that I can see each of these graphs on the left side, I'm going to go over to the right side. And on the right side, I see I got y equals cosine of x first. Well, cosine should start at the top. So which of these 3 graphs down the left side shows it starting at the top? And so then, those two match. Cosine of x has the exact same graph as sine of x minus 270. Because remember, sine and cosine are really the same graph. It's just a matter of where it starts in the pattern or in the wave. All right, next up, negative cosine of x minus 270. Now, you could make a sketch of this one if you're having a little bit of trouble actually seeing where that graph looks. Or you can say, okay, well, I know at 270 it's got to be at the bottom. So I'm going to look down these graphs that I just made. Which one of those has it at the bottom at 270? Notice it's the top one. And so that's actually the same as sine of x. And then finally, process of elimination. Yes, could tell you what the last one is, but we even could figure it out without that, because sine of x minus 90, that means at 90 degrees it's starting at 0. And then it's going up from there. And so that's how we can see that that's the same as negative cosine of x. And so this is actually a type of problem that you're going to be seeing again later today on our assignment as well. The basic strategy, notice, there's a few different strategies you can use, but you can always sketch graphs and then actually match the visual graphs to each other, because we're looking for the ones that give the same graph. All right, the other thing we're going to take a look at here at the start of class today is just how we'd graph something that looks like this. Notice what's different about this graph compared to other graphs that we've actually dealt with and graphed a lot recently. Notice this graph is in terms of pi. Our numbers along our x-axis are in terms of pi. This graph is in radians and not degrees. And you're going to be graphing today on your assignment in radians as well as degrees. But the beautiful thing about it is it's actually pretty much the same stuff you already know. Because, for instance, pi over 2 here. Remember, pi over 2 is the same as 90 degrees. And pi is the same as 180. 3 pi over 2 is the same as 270. And 2 pi is 360 degrees. So all of those are going by the same increments. It's just the different units. But since it's still going by the same increments, we're still going to be putting a point every, instead of 90 degrees, we put a point every pi over 2. So, to make this graph, remember our midline is whatever number is added on to the end. I'm going to go ahead and just go by ones on my scale here. Always start by drawing in these dotted lines. It's going to make your life so much easier. I'm still seeing some people who are kind of trying to resist that. But doing this actually makes your life a lot easier, makes the graphs more accurate, and it helps you. So you definitely want to do that. The 2 is my amplitude. So that tells me that from my midline, I'm going to be going up 2, and I'm going to be going down 2. All right, from there, I'm going to be graphing sine of x minus pi. X minus pi means I'm going to be starting over here at pi. Sine starts in the middle, and then it goes up. Notice the spread of the points. The points are going at what used to be 90-degree increments. Now it's pi over 2 increments. But we always want to go by that same amount each time. Then once we got our points in, you can go ahead and draw your graph that goes through it from there.